Hello, colleague physics teachers. This is teacher Nyangoya from Kisii School. My email is there and my phone number is already displayed. We are in this massive training together, and I want to say, colleagues, we are training. All of us are training, and nobody had prepared for this. And whenever things come, we train to find solutions in between. And this corona has assisted us to learn on how we can be able to teach online, especially when we are not in class. Today, I want to look at activity we were given. We were given activity, that is how to integrate ICT to promote CT and PS in physics. And this is the activity we were given, where we were given two springs, and then we were supposed to determine the mass of unknown masses. So the first thing I did was to place a ruler here. Then I have a stretched length. Then I have resting position, everything. Then I ensure we have a movable line. So I was to line the ruler in a way that I can be able to record a reading. So I took 50-gram mass, hanged it here. Then get the extension. Then known mass that almost seemed alike, and then hanged here. So what I did, that is for the two, so I can be able to use the first extension to determine the second extension, because I ensured the springs strength are the same. The spring strength are the same. So in that, we were able to get this. We set the apparatus as we have seen. We have suspended. So the 50-gram mass was able to give us an extension of 0.08, and the unknown mass gave us an extension of 0.12. So 50 grams gives a stretching force of 0.5 Newton. Then now you can equate, you say 0.5 Newton gives 0.08 meters. 0.12 meters can be able to give what stretching force. And then this is mathematical part. All of you know how to express those ideas. And finally, we arrived at, for this red unknown mass is 0.75 Newton, which is actually 75 grams. Setup 2. So you want to move to setup 2, where I removed this one, then also remove this one. Now in this one, I took 100, hanged it there, took another one, the same. I think the line is the same. Get the extension here. This line, you are just supposed to use it to align across so that you can be able to get the extension. When you look at this, the extensions looks the same. Yeah, we calculated. Then in our calculation, this is what we were able to obtain. 100 gram stretching force of 0.1 Newton gives an extension of 0.16 meters. Then unknown mass also gives 0.16 meters. When you calculate, both of them is like they're giving same stretching force, and therefore the unknown mass blue is 100 grams. Our last activity was getting 250, hang it there, get the extension. Take also the unknown mass, hang it there, get the extension. So this one, you can be able to measure it. You only bring this line here to be in line so that you can be able to read the extension of the meter rule. So get the extension for this one and the extension for that. And this is what we were able to get in that case. 250 grams, a stretching force of 2.5 Newton gave us an extension of 0.41 meters, and the unknown mass gave us 0.3 meters. So when you go ahead to substitute 2.5, 0.14 meters, 0.41 meters, and then 0.33 meters would give us what stretching force. So the stretching force we found is 2.012 newtons, which is equivalent to 201.2 grams. That is how we are able to perform our experiment in determining the unknown masses. So, though there are other ways whereby you can find the spring constant, then start multiplying by the extension to get that, but that was the simplest, just in case you do not want to find the spring constant. That is my activity 1 in ICT integration. Thank you, and I will elaborate the other one later. Thank you so much. Have a nice day.